So, welcome to the Data Friday. My name is Michael Olschimke. I'm the CEO of Scalefree. We do this show here every Friday, 11 o'clock European Standard Time, Central European Standard Time, to allow you, the audience, to ask questions about data vaults, big data, cloud computing, and so on. Everything around that theme, at least. And if we receive multiple questions, by the way, you can use the chat here in the client. You can use the Q&A section. You can send them up front, just what Michael did here. And I'm picking up his question in a minute. And but yeah, you can raise your hand if you want and get voice from me. It's also good. And if we receive multiple questions, I would actually cherry pick those questions so they fit into some team, or I might break them into multiple sessions and so on. And if there are no questions at all, I will talk about the cluster. We're in the summertime at the moment, so we did actually talk about the cluster last 2 times, but now we received questions again. So let's get back to the game. Apparently, the data vault stuff is more interesting than the cluster. I agree. Well, it's actually fun stuff as well, but who cares? So let's get straight into the question here. So there's a couple of questions actually. So around this team, so there will be 3 sessions at least on this scenario here. Not sure if it's all in a row, but we'll see. So the customer or this user here is essentially modeling money transfers, maybe in a bank, and they got some fields from the booking essentially. For example, like some codes, is it an incoming transfer, outgoing transfer, for example, they got their own account ID of the own customer or of their own bank account, and then the opposite account, the counter account number, which is an IBAN number here, some transaction ID, which is nice, so that's not seen very often, the amount in a specific currency, so apparently it's a multi-currency system. So this is apparently some ISO code, EUR for Euro, USD, and so on. The accounting date, transaction date, some title, which is a free-form text, might contain personal data, which becomes another question. And then the address date of the counterparty, again, some personal data. Here we have the model that's being currently used. So we got a non-historized link in the middle. That's in the center essentially. That's the link entity that captures the data. Well, it's known here as a depend child link. Let's talk about that one as well. But yeah, one way or the other, it's a very similar concept. That's why yeah. But I'll talk about the similarities and the differences essentially. And then we have one account hub. Only one, right? Even though there's 2 accounts involved somehow. There's your own account and the counter account. And then you have some satellite attached to the link structure to capture the personal data, essentially. That's PD here. So that's the current model. And the first question is it a good idea to create one hub for the opposite side account, for the counter account? Or should they have only one account for both account numbers, for the internal account number and the counter account number, the IBAN number, even though the structures are different, and the structures might be different for the IBAN formats across the countries, right? So how to model this essentially? Now you got 2 choices apparently. You could have 2 hubs or 1 hub. 2 hubs means you have 1 hub as at the moment. You have 1 hub for your internal accounts, and then another hub for the IBAN numbers. Or you combine it. Let's go for the worst case. Let's assume that the business key for the account, for the internal account, is an integer value, not an IBAN string, right? Just an integer value. And your IBAN number is a string. Starts with, let's say, DE for Germany, and then some number and so on. And some long number. And you have 2 different structures, essentially. Plus, on top of that, the IBAN number might have different structures across the European countries. So how to model this? You could create one hub where you essentially put all these different structures into one single hub entry, one single hub essentially, which means that you have to define a data type which is broad enough to capture all these different data types, strings from the IBAN number, but also the sequence or the integer values, and that would be a string, right? So you could essentially store the integer values as a string as well, just like the IBAN numbers. So just creating one hub with a string data type for the business key, adding all these different identifiers, all these different business keys that identify your business objects in one hub. And that's the idea of the hub in the end. And it's actually my preferred structure, to have only one hub for any structure if I can make it fit. because the hub is defined as a distinct list of all the business keys that are used to identify your business objects across the systems, which means that we're looking at one hub that captures all the business keys if possible. The problem now is, or your limitation is, you're developing a data vault on a relational database, which is very common. So it's not a real limitation, it's all good. But that's a limitation now, because you could argue, if the promise is, if let's say you have different structures for the business key, and they are made up of different columns, different attributes, that might become a challenge, because let's say you have a local customer, 42, and then a customer from the Netherlands, NL 55. And that's two columns, the ISO code, NL, and the local number inside the Netherlands. So how to model this? And I typically, I don't know, so I ask the business user. My question to the business user would be, if we're looking at these different structures, different columns to identify or that define the business key, is it okay for you if we concatenate those two columns, NL52, the ISO code of the country, and the local customer number, if we concatenate that into one string and present it to you in your report in one column? Is that okay for you? And if they say, yes, it's okay, that's how we deal with international customer numbers anyway, then I tend to concatenate these strings and move them into one string in one hub, right? Combine these with the local numbers from, I don't know what I said, from Germany with the 42 in Germany, for example. Have one hub for all these different structures, concatenating them. But in this case, I would also not create a delimiter in between, because that's not what the user wanted. They didn't say, well, yeah, we create an international customer number. It's typically DE semicolon 56 or something, right? That's no, it's DE 56. That's the number they would expect from me in the report. So if they say, well, that's weird to add, let's say, the, I don't know, the business unit and the IBAN number, or the opening year and the IBAN number, that's weird to combine, because that's not a business key we work with. We work with that, but in two different columns, two different attributes in the report. In this case, I'm looking at two different, completely different structures. I'm looking at maybe some sequences to identify accounts, and I'm looking at a combination of two columns to identify an account. And in this case, I'm not combining that into one string, because combination means I have to split it later downstream when I'm creating my dimensions and facts and so on. That's when I have to split it again. That's too expensive. So in this case, so here's the counter question. If you're dealing with semi-structured business key definitions, because that's what you have different structures for your business keys now. Why do you use a relational database engine for that? Why don't you use a semi-structured database engine for that? Maybe MongoDB, for example, or maybe a JSON data type in your hub, which is risky. So I wouldn't go that route, right? Typically, but that's a longer story. But not a good question. But that might be an idea, right? So semi-structured, or because we are living in a relational world, creating two different hubs. So my strategy here, even here, will be this. If those different business keys, the IBAN number, the account number, if I can combine them easily into one structure, just by converting integers into string, for example, just like here, I would create one hub, dumping all these business keys into the hub, as long as they don't overlap. If there's a risk that they overlap, let's say the local account number is similar to an IBAN number in structure, and there could be an overlap with other IBAN numbers. In this case, you have to extend the business key in the hub. So you would create maybe some source identifier and the account number. That combination is, again, one structure for all your account identifiers across the enterprise. So one hub. I just extend it to make sure I'm dealing with potential overlaps. If you're dealing with business keys, which have completely different structures, the number of attributes and so on. I mean, it's a number of attributes which differ. In this case, I'm creating, because I implement these data vault systems as well on relational databases a lot, I tend to create different hubs for those structures. So one hub per structure. So when we define the hub as a distinct list of business keys that are used to identify your business objects, we omit having the same structure, because you're on a relational database. And again, it might be not true on different systems. Like on MongoDB, there's an interesting blog article series that we have on our blog, how to develop a data vault on MongoDB. Everything looks different, to be honest. And in MongoDB, you might have different structures for every entry. Who cares? It's a semi-structured database, right? So that's the other side of the story, right? So that's why the definition is correct, because you don't have to implement a data vault on a relation database system, right? But if you do, per structure of a business key, I tend to create different hubs essentially, because that's how you deal with that in a relation database, right? If you deal with different structures, you create different relations. Right, so that's the idea. So in your solution here, I would load both the internal account numbers and the IBAN numbers into the same hub here on the left side. If I can fit the structure into one combined structure, right? And then the only thing is you have to refer to this hub twice now, one for the account hash key down here, the foreign key, and then a second time for the opposite account number, right? For the counter account. That's missing here. So two hub references to the same hub essentially, right? Right, so that's number one. That's the first question. And the advantage of that is having less hubs means less entities downstream, and less entities means you have a faster, higher performant data vault model. That's number one. The other thing is what we see often is when, I mean, this situation often happens because customers adding source systems over time. And you might have one structure for the account in this system, or maybe already two structures actually in this system. But when you add the next system to the data vault, you're looking at the third structure and structure number 4 for the next system and so on. So the idea is that the problem is if you create one hub, yeah, if you create essentially one hub for every account number, you're adding a lot of hubs essentially, right? And yeah, and you have to link them. That's the other thing. So you're creating links between those hub structures, I mean, based on incoming source data, but the model becomes bigger and bigger. So I'm trying to avoid that, if possible, by adding all these different business keys into one single hub, except if the structure is different. Then I'm creating a new hub essentially. That's the idea. So I'm trying to avoid creating too many hubs because the purpose of the hub is to integrate data, right? If you have multiple hubs, you're integrating less data. That's what it is. So that's the idea essentially. One more comment regarding dependent child link and non-historized link. Both concepts are similar. In the training, we typically start teaching with the dependent child link, and the idea of the dependent child link is to capture the granularity of the source data, which you do here, because when you add the, well, in this case, the transaction ID should be a dependent child. That is the dependent child here, the most important one. That is part of the alternate key or unique key constraint of this link. So it should be, if I understand your data correctly, there should be two account numbers in it, which are the hub reference. They are part of the hash key computation anyway, right? And then you have the transaction ID. Those three elements should be the input, well, the business keys behind those hash keys, and the transaction ID is the input for the hash computation of the link. Those three elements, the two account hash keys and the transaction ID, are your alternate key on this table or unique key constraint that allows you to capture one record per incoming transaction in the link, right? That's the goal of the dependent child link. And then we realize also that there might be, in a dependent child link, the idea is that we have a like a line order item where we have multiple line orders. That the fact consists of multiple records essentially. That's the idea, and the line item number distinguishes those individual rows that make up the same fact. Now, that's one thing. So it's like the dependent child link is really about capturing the original granularity from the source. And then we talk about the non-historized link, and that's where we essentially teach that you can denormalize descriptive attributes from a satellite into the link structure itself. And that's what you do, what you did here as well, like the flow type and currency and the amount, for example, and transaction date, for example, accounting date, and so on. You added all these descriptive fields here into the link structure itself. I wouldn't call them dependent child. It's just descriptive data you denormalized into the table. So we call this descriptive data. But dependent child is the distinguishing element here, the transaction ID. That's what we call dependent child. So the thing is this: in your case, You could argue both. Is it a depend chart link or non-historized link? And to be honest, I do the denormalization and the granularity issues I capture by both link entities. So what's the difference? The difference is quite simple. When I'm looking at multiple records that define the fact, let's say invoice line items defining an invoice, market basket items in your market basket, in your retail store, in your retail basket, define your market basket, right? What you purchase, that kind of stuff. In this case, I'm using a depend child link. And then the depend child is maybe the line item number or the position number on the basket and so on. That's when I call this a depend child link. If your facts are defined by one and only one record, could be a semi-structured record, a JSON message, for example, or a real-time message, XML message or something, but one single record in your relation defines the fact, then I call this a non-historized link. That's it. The trick, I mean, the granularity, capturing the original granularity, I do in both cases. So I'm extending the hash key combination by another element, transaction ID, market basket ID, whatever, or in this case, maybe the transaction ID. I'm adding this element to the alternate key to be able to capture the granularity from the source system, one-to-one. That's trick number one. And the second trick, denormalizing descriptive attributes that I need for the aggregation. What you do here as well, the amount, the amount, the transaction dates, right? You need that for delivering those facts into a fact entity and for the user to quickly do some aggregations on it, grouping by the hub references, the accounts, but also grouping by the dates and so on, and then aggregating the amount. That trick is from the non-historized link, but I do both the granularity and the denormalization. I do both for depend chart links and non-historized links. And the difference is really depend chart links is where the fact consists of multiple rows, where a non-historized link is only one row, one fact. That's the idea. It's for the data scientists, power users, data developers to better understand the different granularities in those entities. That's how I use it, essentially. That's the idea. So to give them a quick start, how to use these entities. Because for the depend chart link, they have to consider multiple records often, right, at the same time, some way or the other. So that I want to make them aware of that. That's it. That's the difference. That's at least my modeling style, let's say. All right, so that's question number one and answer number 1 and 2, right? So I'll give you a bit more. Yeah, so, and we will discuss the rest in next week and the week after, most probably, because there's a couple of more questions around the satellite here, as far as I remember, and on the currency symbol. So we need to talk about those options. All right. Just double check. Yeah, the comment here, the opposite account is missing on the picture. That's another hub reference to the same hub, right? So that's the idea. Cool. Yeah, one first advertisement here on the channel, right? So we have a conference coming up, what we call the Data Dreamland 2022. That's a data-driven conference. The theme is really data-driven business value. How do we, as a data warehousing community, deliver business value, data-driven business value to the end user? So it's a lot of business topics, a lot of enabling business by data, essentially, or data-driven solutions. That's the theme of the conference. That's a lot of these of our speeches of the conference submissions is really about that. We have an interesting set of speakers from the industry. It is on site in Hanover, Germany, on September 13 and 14, 2 days, one track, but very interesting stuff coming up. So take a look at it. Check out the website. Go to scalefree.com to check out if you can attend. It will be fun, and I'll be there. So good chance to say hi, because I don't see your face here anyway. So it's just me here presenting. It's a bit boring in my opinion, but hey, you're coming. Some of you coming back, getting less and less over the summer break apparently. So yeah, if you have a question like this, like Michael, thanks for that. Use this form here, sfr.ee/dbfriday. That's where you can type in your question, and just as what Michael did, upload some pictures if it helps, right? Which helped actually, and yeah, send your questions and I'll schedule them essentially. All right, cool. Thanks for that. Hope you enjoyed it today. Enjoy your weekend. This weather is okay in Germany at least, but maybe better in your spot wherever you are. And yeah, enjoy the weekend. See you next Friday. And yeah, thanks guys.
Thanks for joining today. If you'd like to discuss this further, give us a call on the number below here, and we're happy to discuss this with you. See you next time. Have a nice weekend. Bye-bye.